Hi everyone, today I am going to discuss the basic concept of gravitation in this video, and at the end we will discuss few questions from this part only. And in the next video we will continue this chapter with interesting questions from whole chapter. And remember, this is according to the standard 9. So if you were a student of class 9 of any board, then this is really going to help you a lot to prepare this chapter for exam. So let's start gravitation. So we observed that when we throw a ball up, it goes a certain distance upward, and after reaching certain height, it will again fall back. So according to Newton's first law of motion, a body at rest moves only when a net non-zero external force acts on it. So when a ball went up, you had applied force on it. Then why did it fall back? Which force is responsible for it? Yes, it is Sir Isaac Newton. When he observed an apple falling from a tree, he concluded that the earth must be exerting a force of attraction on the apple, and hence it gets accelerated towards it. He also proved that this force of attraction is not confined between the earth and other bodies on the earth, but this force exists between any two bodies anywhere in the universe, which is called the force of gravitation. So let's see. According to Newton's law of gravitation, every object in the universe attracts each other by a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers, and this force acts along the line joining them. So we are getting some concept of the magnitude of force and also the directions of force. So if there are two objects A and B, they are having the masses m1 and m2, the distance between their centers is r. So F, the force of gravitation between them, is directly proportional to the product of their masses. So remember, the product of their masses. And this force is also inversely proportional to the square of the distance between their centers. So as the distance between their centers is r, so F proportional to 1 by r square. So from this law, we can get the idea of magnitude of the force, which is proportional to the m1 m2 product of their masses and inversely proportional to the square of the distance between them. So if A object is applying a force on B, then it is along this direction, and obviously B will also apply the force on A along this direction. So according to Newton's law, these two forces are same, but they are in the opposite direction that we can see. So this Newton's law of gravitation also follows the Newton's third law of motion. The force, the action and reaction are equal and opposite. Now let's see the mathematical expression of this force, which is F proportional to m1 m2 and proportional to 1 by r square according to Newton's law of gravitation. Now if we combine these two, so we are having m1 m2 by r square. So for the proportionality constant, we will have g. So F equals to g m1 m2 by r square. Now this g is called universal gravitational constant. Okay, so here the values of g I have written here 6.67 into 10 to the power minus 11. Now 6.67 into 10 to the power minus 8. So obviously that we have understood this, these two values are in two different unit of system. So let's find the unit of G. So G equals to Fr square by m1 m2. So to find the unit of G, we need to use the unit of force, that is 1 Newton, unit of R square, that is 1 meter square, unit of m1 m2, that is 1 kg and 1 kg. So it is 1 Newton meter square per kg square, or also you can write 1 Newton meter square kg to the power minus 2. So that is in SI. So 1 dyne centimeter square gram to the power minus 2, that is in CGS. Now we can write this here. So it is 1 Newton meter square kg to the power minus 2, and here it is 1 dyne centimeter square gram to the power minus 2. So I hope you have understood. But here it is 10 to the power minus 11, 10 to the power minus 8. So how it is coming? So let's see how to find this relation. So G equals to 6.67 in 10 to the power minus 11 Newton meter square kg to the power minus 2, that is in SI unit, and this is in CGS unit, CGS system. So let's find how to convert SI to CGS. So in SI the unit is 1 Newton meter square per kg to the power minus 2 per kg square. So 1 Newton equals to 10 to the power 5 dyne, and 1 meter equals to 100 centimeter. That means 10 square centimeter. So 1 meter square equals to 10 to the power 4 centimeter square. So that's why 10 to the power 4 centimeter square. Now here it is kg to the power minus 2. So 1 kg equals to 10 to the power 3 gram. So 1 kg square equals to 10 to the power 6 gram square. So 1 kg to the power minus 2 equals to 10 to the power minus 6 gram to the power minus 2. So here you can convert kg to the power minus 2 as 10 to the power minus 6 gram to the power minus 2. So if you simplify 10 to the power 5 here, 10 to the power 4 here, 10 to the power minus 6 here. So 5, 4 and minus 6, 9 and minus 6, if you combine, you will get 10 to the power 3 into 1 dyne centimeter square gram to the power minus 2. Now 6.67 into 10 to the power minus 11, this is the value in SI. With this we have Newton meter square kg to the power minus 2. So now if we replace this SI unit with CGS, so Newton meter square kg to the power minus 2 will be replaced by 10 to the power minus 3 dyne centimeter square gram to the power minus 2. So 10 to the power 3 and 10 to the power minus 11 will give you 10 to the power minus 8. So in CGS system it is 6.67 into 10 to the power minus 8 dyne centimeter square gram to the power minus 2. So we have understood what is gravitation. Now let's see what is gravity. We often use this term gravity. So the gravitational force between Earth and any other object in this universe is called gravity. Okay, so it is exactly the gravitation, but one object is Earth and another object it may be anything. So the gravitational force between Earth and any other object is called gravity. Now here we have G, which is called universal constant. So why it is called universal gravitational constant? Why it is not a simple constant? Okay, so let's see the points. So the value of G, which we discussed, 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2 in SI. So this value of G, whatever it is in SI or CGS, is same at all points for all objects in the universe at all times. So there are 3 points. It is same for all points, for all objects, and for all times. Okay, so whatever may be your objects, whether it is proton and electron, whether it is sun and earth, whatever you will do in the universe, whenever you will do, you will have the same value of G, and that is equals to this. Now let's discuss the nature of gravitational force. So this force is always attractive, so that we have understood that gravitational force is always attractive. Now number 2, it follows Newton's third law of motion. That also you have understood, that the force between two objects F1 and F2, both are in the opposite direction but their magnitudes are same, so they are following Newton's third law of motion. Now number 3, it is very weak force in nature. Okay, so there are few forces, other forces in nature, so this force is weaker with respect to the other forces. Okay, number 4, it is non-contact force. Obviously it acts at a distance, so it is non-contact force. And number 5, it is inverse square force. So why it is inverse square? Because force proportional to 1 by r square, this nature, if the mathematical expression of this force, of any force, is this, then we can say that force is inverse square force. Hope it is clear to all of you. Now let's do few numericals on the concept taught till now. So the first problem, the gravitational force between two objects is 4 Newton. What will be the gravitational force between these same objects if the distance between them becomes double? So first you need to understand what is the relation of the force with distance. It is inversely proportional to the square of the distance between the centers of the objects. So if we decrease the distance, force will increase, and if we increase the distance, force will decrease, inversely proportional. So here it is given becomes double. You can see here it is given becomes double. So if it is double, that means the r is changing. So initially it is r1, finally it is double, so it becomes r2. The objects remain same, their masses are same, m1, m2, and when it becomes r2, then also their masses are m1 and m2. So obviously force will change. So for the first case it is F1, here it is F1, and here it is F2. So F1 is obviously G m1 m2 by r1 square, and F2, the r is changed, r1 is changed to r2, so it is G m1 m2 by r2 square. Now we need to find that what will be the new force if the distance between them becomes double. So we will take the ratio F2 by F1. So it is G m1 m2 by r2 square, G m1 m2 by r1 square. So we are getting r1 square by r2 square. So we can write r1 by r2 whole square. So F2 equals to, finally we are getting F1 into r1 by r2 whole square. So F1 is 4, it is given 4. Now 4 into r1 by r2. Now r2 is double of r1, that means 2r1. So r1 by 2r1 whole square. So r1 will cancel. So we have 1 by 2 whole square, that means 1 by 4. So it becomes 1 Newton. So what we discussed earlier, that if the distance will increase, force will decrease. So initially when the distance was r1, so the force was 4 Newton. So if the distance becomes double, the force becomes 1 Newton. So it is decreasing. So the new force will be 1 Newton. That is the answer of this question. Now let's discuss the next sum. The gravitational force between two objects is 50 Newton. How much distance between the objects be decreased so that the force between them becomes double? Now the force is becoming double. So to make the force double, what will be the distance? How much the distance between the objects be decreased? So obviously we have understood that if we decrease the distance, then only the force will increase. So how much we need to decrease? That we need to find. Very good. Now let's find. So F1 equals to G m1 m2 by r1 square, and F2 equals to this G m1 m2 by r2 square. So F proportional to 1 by r square. So we can write directly that F2 by F1 equals to inversely proportional, so it will be r1 square by r2 square. So r2 square equals to, we are getting r1 square into F1 by F2. So F1 by F2, as it is said, the new force will be the double of the initial force. So F2 equals to 2F1. So we are replacing F2 as 2F1. So F1 will cancel. So it becomes R1 square by 2. So R2, the new distance, will be R1 by root 2. So the distance must be decreased by 1 by root 2 times of the initial distance. Yes, so according to this MCQs, let's see. The gravitational force between two objects is F if masses of both objects are halved without changing distance between them. Then the gravitational force would become F by 4, F by 2, F and 2F. So F proportional to m1 m2 by r square. So it is m1 by 2, m2 by 2, and r remains same. So obviously it is becoming 1 by 4 F. So the option A is correct. Now, gravity is the force of attraction between. There are four options: the sun and the moon and the satellite, the earth and an object, the sun and Jupiter. So according to the definition of the gravity, the force of gravitation between the earth and any other object in the universe is called gravity. So option C is the correct option, the earth and an object. Now, question number 3 MCQ. The value of G in the law of gravitation depends on, the four options are there: mass of earth only, radius of earth only, both mass and radius of earth, and number D, independent of mass and radius. So already we discussed that G depends on, it is independent of anything, that is, it is constant. G equals to 6.67 10 to the power minus 11 in SI unit, and it is same at all points in the universe at all times for all objects. So it is independent of mass and radius. So option D is correct. Now this is the calculation of the first term. Now I am giving you one homework which you will try at home. An object is in between the earth and another planet P. The force on the object by earth is balanced by the force due to the other planet P. How far is the object from earth? The distance between the planet and the earth is 15 into 10 to the power 9 meter. It is given. And mass of the planet is 2.25 into 10 to the power 6 times the mass of the earth. So you please try this at home, and next day we'll discuss the answer of these questions. So to see the videos on gravitation, please keep watching this channel. Thank you. Bye.